Okay, so page 17 is a test review that will cover everything that's on the test. 15 through 21, the rest are also really good practice. So for number 1, we are going to find the area between the curves. So what that means is first you have to graph both equations in your calculator. And we get the picture here, A. I'm going to zoom in, and you have to find the intersection points. So to find the intersection points on the calculator, you're going to do second trace, choice number 5, and arrow to the point that you want and hit enter 3 times, and that will get you the intersection point. So for A, the x value on the point on the left is -2, and the x value of the point on the right is 1. So that means our integral is going to go from -2 to 1. Then we have to decide which graph is higher and which one's on top. So if I look at my picture, I see that the quadratic up here is the higher graph. And I put that in my first f of x. So we're going to do f of x minus g of x as the value of our as the order of our subtraction when finding this integral. If you put f of x in y1 in your calculator, then you would have y1 and y2 when you do math 9. You don't have to do the fundamental theorem of calculus. If it just says find find the area between the two curves, you can use the calculator to calculate the integral of math 9 and get your answer. Okay, so let's set up B. Again, you're going to graph the two equations. Let me zoom out so you can see them. I'm actually recording for the first time on my phone versus the iPad, so I have a much smaller screen. So if I seem zoomed in really a lot on your computer, it's because I'm using a phone screen instead of an iPad screen. Okay, so for B we have f of x, and that's going to be the parabola that's faced up, and g of x is the parabola that's faced down, because it's the negative coefficient. So again, in your calculator, you want to find the two intersection points. On the left, it's going to be 0, and on the right, they intersect at 3. So our integral goes from 0 to 3. And if I think of this area in between, the graph that's on top is the g of x. So when you calculate that in your calculator, with math 9, make sure that you put the negative x squared graph, which was g, first in your subtraction. Okay, so then for C, we have a cubic. That was f of x. And then it's hard to see, but when y equals 0, that is the x-axis here. That's our g of x. So my intersection points, there's 3 of them now. On the left, we're at -1. In the middle, it's at 0. On the right, it's at 1. And so that means I'm going to actually have to do 2 integrals to be able to get the total area. Because if you think of the section here on the left, the top graph is f of x. But over here on the right, the top graph on this section is g of x. So you have to, in your calculator, individually calculate each integral. So you'll do -1 to 0 in math 9. You do 0 to 1 in math 9, making sure to switch the order of your equations, and then add your two values together. D is going to have two sections as well. Let me get my equations. Okay, so 3x to the third, that's this graph. And then the parabola is g of x. Okay. So my intersection points, you graph both. You're going to do second trace. The calculate menu, choice number 5 is intersect. You put your cursor on all three. You have to do it 3 times. So the one on the far left is at -3. The one at the middle is at 0. And the one on the right is at 2. So I'm going to have the integral from -3 to 0. I'm going to add that to the integral from 0 to 2. So over here from -3 to 0, the top graph is the cubic f of x. And then over here on the right graph, and here, the top graph is the quadratic, so that's going to be g minus f. Individually, you're going to find this antiderivative in the calculator. I'm sorry, integral. You're going to find this integral value in the calculator and then add them together. Okay, for number 2, average value, that's 1 over b minus a. So it's always the big number minus the small number times the integral So I'm going to simplify the fraction in the front. 2 minus -2 is 1/4, not negative. In the calculator, you have to math 9 your integral. Find this with math 9 and get a value here, and then multiply them together to get your final answer. Oops. Okay, I guess I can't delete that. There we go. And now for b, I'm going to set it up the same way. It's the 1 over 2 minus -1 times the integral from -1 to 2. Again, use your calculator to calculate it. It's going to be the same thing for C and D. Okay, for number 3, find the antiderivative. So this is from our prior unit, but it's really good review. It's on our test for this unit a little bit. It is on our quarter exam, which is next. So for A, to find the antiderivative, I first have to make it so that the the variable is not in the denominator. Now that I have x to a power, I can add 1 to my exponent divided by the exponent plus c. I'm going to change this a little bit because I don't like a negative exponent in my answer. I'm going to move this back to the denominator. So we get 1 over -2x squared plus c. So the power rule is when you add 1 to the exponent and divide by the new exponent. So we can do the same thing for b. I first have to change that 1/2 into an exponent, and then I can do the power rule. So 1/2 plus 1 is 3/2. That will be my new exponent, divided by 3/2. But we don't like dividing by a fraction. So it's the same to multiply by the reciprocal, and that is my simplified answer. Delete all that. Okay, for C, we're going to find the antiderivative of each piece individually. So when you have 3x to the fourth, the 3 coefficient carries down. Add 1 to my exponent over my new exponent. The 5 coefficient carries down. Add 1 to my exponent divided by the new exponent. X to the first becomes x squared divided by 2 plus c. And now lastly for D, because we have x minus 1 to the fourth, you could do x minus 1 times x minus 1 times x minus 1 times x minus 1, but that is a lot of work, so I'm going to do it a shorter way. When we have a function within a function, I'm going to say that the inside function is u. Then from here, I'm going to make my integral u to the fourth dx. But I can't mix u's and x's. So I'm going to go to my u function and take the derivative, and I want to replace this dx. So I'm going to manipulate my du equation around by multiplying dx to the right. And I see that I can replace du with dx because they're equal. Because dx here equals du, I can take this dx and replace it with du. Now that I'm in a spot where everything's the same variable, it's a very basic equation, u to the fourth, I can do the power rule, u to the fifth over 5 plus c. But I'm not quite done. The last thing I have to do is replace my u back in. And I'm done. Now number 4, capital F means antiderivative. So all number 4 wants you to do is take these x values, the 2, the 3, the 1, and the 1, and plug it into your answers from number 3. So since I deleted all my answers, I'm just going to do D, and we're going to plug in 2. So we get 2 minus 1 to the fifth over 5 plus c. So 2 minus 1 is 1. So this is 1/5 plus c. Okay, now lastly for number 5, we have the fundamental theorem of calculus. It is going one step further from the antiderivative that we did before. So for A, I'm going to find my antiderivative. But I need to remember that I have the numbers 1 and 4. So now what we do with that is we take our top number and substitute it in for x, minus, take the bottom number and substitute that in for x. And then we have to simplify. You have a calculator. I'm going to do this by hand. 8 plus 4 is 12, minus 1/2 plus 1 is 3.5. I'm going to make a common denominator. And we get 21 over 2 as the answer for A. or as a decimal, 10.5. Get myself some space. Okay, so for B, I had said on the board you can skip B. That is a special antiderivative. We're not going to do it. For C, the antiderivative, add 1 to the exponent divided by the exponent for each term from -2 to 3. I am going to simplify. 8 divided by 4 gives me 2x to the 4th plus 3x squared over 2 plus x. Oops. And I'm going to plug in the 3. I'm going to find that as a value. Minus, and plug in the 2, the -2. And you will simplify all of those, subtract, and you should get 142.5 down here. Okay, and last but not least for D, my power rule, add 1 to the exponent over the exponent. -1 becomes x. So I will plug in 2 minus plug in 1. And simplifying, this is 8/3 minus 2 minus 1/3 minus 1. This is 2/3 minus -2/3, and we get 4/3 as an answer.